In this project, we simulate a corporate IT environment in which an HR web portal is exposed on an internal network. To keep the setup realistic and isolated, we use two virtual machines, a Kali Linux machine as the attacker and a Ubuntu machine as the target server. The target web application is DVWA. It is designed to replicate the vulnerabilities in the web application. On the Ubuntu virtual machine, MariaDB runs as the backend database and stores the user's account and password hashes. In the first step, I'm validating the environmental setup. The aim is to show that both virtual machines are live, correct, addressed, and connected. On Kali, I run the first code to confirm the internal IP address is 10.0.01. Then I run the second code to verify the connectivity to the Ubuntu target machine. On Ubuntu, I run the first code to confirm the internal IP address 10.0.0.1.02 where DVW is hosted. Finally, I open the DVW login page from the Kali browser. This confirms that the target application is reachable. Next person.
Before launching the attacks, we first prepare DVWA by logging, resetting the database if needed, setting the security level to low, and copy the cookie from browser. This made sure the target was in an unprotected state and allowed session-based attack to work properly. We then demonstrate three attacks. First, network reanalysis using Nmap. A basic scan shows open ports, and a deeper scan on port 80 reveals web service details, including the app cache version. This helps identify the target's attack surface. Second, SQL injection. We use a Boolean-based payload to bypass the query condition and return all user records. Then a union-based payload to extract user names and password hashes from the database. The admin MD5 hashes was then cracked in crack station, revealing the password. Third, brute force. We use Hydra with the admin surface, the Rocky word list, the session cookies, and the login failure condition to automate password guessing. Since there was no lockout or rate limiting, Hydra found the correct password almost instantly, and we successfully logged in admin and password. Next, please.
So in the third step, we will show how the firewall will be implemented. So layers 1 to 3 form the active blocking stack. The IPS inspects every incoming request and drops anything containing the SQL injection patterns. The logout layer tracks failed login attempts per username and applies an exponential backoff penalty, and the rate limiter enforces 20 requests per 30 seconds. Layer 4 records every security event with a timestamp to the audit log, feeding to the real-time dashboard, and layers 5 to 7 focus on data protection and resilience, where the IP addresses are pseudonymized before being written, and the log file itself is encrypted at rest, so an attacker sees only ciphertext. And TLS encrypts all traffic between the client and the firewall, so credentials cannot be intercepted in transit.
To verify WAF is working, we will rerun the same attacks through the WAF. First, we'll do the SQL injection. So we open the DVWA and enter the same payload as the step 2 and the union payload as well. We'll see the 403 forbidden for both payloads, which shows that the WAF blocks the SQLI. And then we'll try the brute force. So we'll run the same Hydra dictionary attack the Gordon account. You can see the correct password ABC123 is at position 10 in the list, but Hydra passed that because the account is locked after 5 failed attempts. Then we can open the live dashboard to see. As you can see, the counter has increased. There are 2 SQLI being blocked and 1 lockout event, which record is correctly. And then we'll inspect the encrypted audit log. As you can see, the log file contains only encoded text, so that attacker who gains the file system access cannot read any event details. And for the decrypted log, you can see that the log contains entries for every event with timestamps, confirming that encryption is working as we expected. Finally, we'll click the padlock button on DVWA and more information, and then click View Certificate. It shows the certificate details and confirming that the WAF auto-generated a valid TLS certificate on startup.